Coordinate geometry, the circle. Okay, so the equation of a circle with center 0, 0 and radius r is given as x squared plus y squared is equal to r squared. So that's the equation of a circle whose center is at 0, 0 and radius r. And we can see there's a point on the circle, its coordinates are x and x along the x-axis and y up the y-axis. The coordinates of the point on the circle are x comma y. Okay, so let's look at an example then. Finds the equation of a circle with center 0, 0 and radius 1 and 1/4. Okay, well, the first thing we want to do is to convert our radius from a mixed number into an improper fraction. Okay, so 4 by 1 is 4 plus 1 is 5 over 4. And that is our radius. And because the center of the circle is at 0, 0, we can say that the equation of the circle must be x squared plus y squared equal to r squared. And so that's x squared plus y squared equal to 5 over 4 squared is 25 over 16. And just to kind of lose this 16, we'll multiply all the terms by 16, and they'll cancel, and we'll get 16x squared plus 16y squared is equal to 25. That is the equation of the circle whose centre is at 0, 0 and whose radius is 1 and 1/4. Second example, find the equation of a circle with centre at 0, 0 and which contains the point 4 minus 1. So there's a point on the circle, it's here, it's out 4 on the x and down minus 1 on the y. Okay, and so we need, for the equation of a circle, we need it in the form of x squared plus y squared equals r squared, so we have to find r. And r basically is the distance from 0, 0 to 4 minus 1. Okay, so 0, 0, 4 minus 1, name them x1, y1, x2, y2, and use our equation to find the distance between 2 points from coordinate geometry, the line, we would have done it there. The distance between 2 points, x1, y1, x2, y2, is given as the square root of x2 minus x1 squared plus y2 minus y1 squared, and plugging in our values here will tell us that the radius is equal to the square root of 17. So because the centre is at 0, 0, the equation must be x squared plus y squared by r squared, which is root 17 squared, and that's x squared plus y squared root 17 by root 17 is 17. X squared plus y squared equals 17. That's the equation of the circle. And just remember from your third chapter in indices that the square root of any number squared is equal to that number itself. Now, let's look at how to find the radius of a circle given the equation for the circle. Okay, so the trick with these, that's what that should say, trick, is to reduce the equation to the form x squared plus y squared equals r squared. So here's an example. Find the length of the radius of the circle. 9x squared plus 9y squared is equal to 16. So we want to try and get rid of the 9's. So if we divide all the terms by 9, they'll cancel out, and we'll have x squared plus y squared equals 16 over 9. So r squared, that must be r squared if this is the equation. R squared is equal to 16 over 9, so r is the square root of 16 over 9. Square root of 16 is 4, and 9 is 3. So the radius is 4 over 3, which is 1 1/3. Let's just consider points and their location with respect to circles. Okay, so a given point P may be inside, on, or outside a circle. Inside, on, outside a circle. Okay, for this one here, the distance from the center 0, 0 to P is less than the radius of the circle. Okay. And for this one, the distance from the centre to P is equal to the radius of the circle. And for this one, the distance from the centre to P is greater than the radius of the circle. So if we find a distance and compare it to the radius, we'll be able to tell if the point is inside, on, or outside the circle. So is the point 3, comma minus 2 in, on, or outside the circle whose equation is x squared plus y squared equals 13? Okay, how do we solve this? X squared plus y squared equals 13. This is r squared, so r squared must be equal to 13, so r must be the square root of 13. Okay, that's the length of r. Now we're going to find what the distance is from the centre to this point at 3 minus 2, and finding the the length of the length between 0 and the point P here, using our coordinate geometry formula. This one will be x1, y1, x2, y2. We can see that the distance is the square root of 13. So the radius is square root of 13. The distance from the centre to P, according to this, is root 13. So they're one and the same, so the point must be on the circle. Okay. Another way we could have done this is we could have simply subbed in the x value for 3 into the equation, the y value of minus 2 into the equation, x squared plus y squared is equal to 9 plus 4 is equal to 13. And because that's equal to 13 as per the equation holds true, that tells us that the point with these coordinates 3 minus 2 is on the circle x squared plus y squared equals 13. By putting x in here and y in there, we get 13. The equation holds true. Okay. Just to note that if this value here was greater than r squared, the point would be outside the circle, and if this value calculated was less than r squared, it would mean that the point is inside the circle. Now let's consider circles whose centre is not at 0, 0. So let's look at the equation of a circle with centre h, comma k and radius r. Okay, and the centre is not at 0, 0. So that's what makes these circles different from the prior ones whose centre was at 0, 0. So the equation of such a circle is given by x minus h squared plus y minus k squared is equal to r squared. So here's an example. So let's go to this. Okay. Find the equation of the circle centre 2, comma minus 3 and radius 5. So the equation is x minus h squared plus y minus k squared is equal to r squared. So 2, comma minus 3 is 2 is our h value and k is our minus 3 value, and r is 5. We have that from here. So we simply just plug in the values. That becomes x minus 2 squared plus, be careful, y minus k, which is minus 3. So always be careful with these, we see the minus sign. That's all equal to 5 squared is 25. So our final equation is x minus 2 squared plus y plus 3. Minus times minus is plus 3 squared. Okay. Now, how to find the centre and radius of a circle given the equation. So find the centre and radius of the circle whose equation is x plus 3 squared plus y minus 4 squared equals 8. Okay? Well, first of all, r squared is equal to 8, so r is equal to the square root of 8. Okay, so we found the radius already. Now, we need to compare the equation we're given with the standard equation. So the standard equation looks like this. The equation we're given looks like that. So we need to say that minus h equals plus 3. H must be equal to minus 3. Because we multiply both sides by minus 1 to get the positive h value. And minus k is equal to minus 4. Okay, so that's from there. So k, multiply both sides by minus 1, clean that negative k up, and we get k is equal to 4. So h comma k is minus 3 comma 4. R is equal to the square root of 8. So be careful with this trick here. It's very good just to write what you see. Minus h equals plus 3, minus k equals minus 4, and solve. Okay, circle with centre 1, comma 3, pass through the point 3, comma 5, find the equation of the circle. Okay, so the point, the circle passes through the point 3, comma 5, so point 3, comma 5 is on the circle. So the distance from the centre, which we know, to the point must be equal to the radius. So name one x1, y1, the other x2, y2, and then plug it into the equation to find the length of, or the distance between those 2 points, and you'll find that the distance, or the radius of the circle, which is the distance between the 2 points, the centre and the point on the circle, is equal to the square root of 8. So r squared is equal to 8. Okay. Now the equation for the line is x minus h squared plus y minus k squared equals r squared. hk is 1 comma 3, so the equation must therefore be equal to x minus 1 squared plus y minus 3 all squared is equal to 8.